Right. Welcome, folks, to the last set of 10 questions to do with functions and transformations. Now, this time around, we are interested in drawing a table and sketching the function y equal to x cubed. So, if we are to draw a table, we will need something of this nature. And what we saw from the earlier discussions is x, because we want to draw, you can roughly run it from 1 maybe up to 3 there to just have an insight of the picture that we'll get. So when our x is minus 2 in that function, minus 2 cubed gives us minus 8, minus 1 cubed minus 1, 0 cubed 0, 1 cubed 1, 2 cubed 8, 3 cubed 27. So what we can see is on our Cartesian plane, we'll be having something of this nature, x, y, and there is our origin 1, 2, 3, 1, 2, 3. So it's minus 1, minus 2, minus 3, 1, 2, 3, like that. And vertically, we can choose to move from minus 2, minus 4, minus 6, minus 8. And here we can have 2, 4, 6. We just want to have a look at the rough picture of this particular curve. So for this set of coordinates, minus 2, minus 8, minus 2, minus 8 is this point here. Minus 1, minus 1, minus 1, minus 1 will be somewhere there. So minus 1, minus 1, somewhere there. That's where they will interact. And there we have 0 and 0. Then here we have 1 and 1. It will be somewhere there. And then we have 2 and 8. It will be somewhere at the top there. So let me roughly join my points using a black marker to say we have something of this nature. So that's the function y equal to x cubed. Then next we just want to sketch the function. Let's have a look. Our interest is on the function y equal to 1 over x squared. Because we're sketching, one thing we know is that the square of x is never negative. So this is a function which is not found in negative y. So it's x and y there. We have a picture like that. That's y equal to 1 over x squared. Then moving on, we are interested in drawing y equal to x squared minus 4 and finding its roots. So what we will do is we will have a look at the transformation that we have. So that's why. So I can start with y equal to x squared, which is a graph like this, y equal to x squared. And when I say minus 4, it means a vertical shift 4 units downwards. So somewhere where it says minus 4 there, I'll have this similar picture. The turning point will be there. So that's y equal to x squared minus 4. But then my interest is on the coordinates of this point. Those are going to be the roots. So I'll try and do it algebraically to say, but that point is a point where our y is equal to 0. And that will give us x squared being equal to 4. So x is actually plus or minus 2. So in whatever we do, this is going to be approximately minus 2, approximately positive 2, provided we have used a correct scale and markings. Then next we're interested in sketching y equal to 3 to the power x, so I have my x, so I have my y. I can roughly pick maybe 1, 2, 3 points to see the overall picture is this curve is growing. So when my x is 1, 2, 3, going to the negative side, it will approach as much as it can closer to 0, but it doesn't touch. So in other words, we are saying 0 is an asymptote here. So we have a horizontal asymptote. Then what do we do? When our x is 1, y is 3. So this is 1. So we expect something like that. So this is going to be a rapid increase. In other words, we have something of this nature. That's y equal to 3 to the power x. Because when I put um, 3 squared, that will be 9. 3 cubed, 27. It will be stretching going up very fast. So let's move on. State the asymptote of our exponential graphs. So the asymptote, we are saying the asymptote is um, y equal to 0. That's the asymptote, y equal to 0. In other words, we are saying we don't touch the x-axis or the horizontal. Then moving on, um, let's see the next problem. Find the turning point of that given curve. So if we want the turning point, rather we'll complete the square. And when we are completing the square, we divide this part by 2, gives us minus 1, then squared. And when I square minus 1, it gives me positive 1, but I don't have a positive 1 there. Actually, positive 1 is there. So it means we have completed the square. So this is my P, and we're supposed to have plus a certain value C there, which happens to be our Q. Because there's nothing, it means the turning point is going to be made up of 1 and 0. Then moving on, solve x minus 5 graphically equal to 0. So in doing this, we need to rearrange that. This is x squared equal to 5. And what are we saying? On our Cartesian plane, we are interested in two graphs, and we look at their points of intersection. Because when we break or split this, we're having graphs of y equal to x squared, y equal to 5. Let me pick a black color to say, but y equal to x squared, if I'm to sketch it, it's a sketch like that. That's y equal to x squared. And for y equal to 5, this is just a horizontal line passing through the point y equal to 5. So what's of interest here is the coordinates of these points. So in other words, I'll draw vertical going through the x-axis. I'm interested in determining the points where those lines intercept the x. So I'll do it algebraically, but say algebraically, simply saying x is equal to plus or minus root 5. So approximately here, we should be having a marking of minus root 5. And here, approximately positive root 5. That's what we'll get there. Then next, we're interested in sketching the graph of y equal to x squared and y equal to negative x squared. Let me bring my Cartesian plane here and say, but this is x, y. If I want graph of y equal to x squared, which is normally the easiest graph because it's basic, that will be like that. Then y equal to minus is like I'm reflecting in the y-axis, so it will be giving me the opposite, which will be a curve like that. That's y equal to minus x squared, something like that. Let me move on. Describe the transformation from y equal to x squared to y equal to x squared minus 3. I'm just describing, so when I check, this part gives me a vertical shift, so I can say drop the graph 3 units downwards in the y. I think that's the transformation we have. Now, explain the difference between sketching and drawing. Well, with the drawing, needs points to plot, um, but with sketching shows special points. When I say special points, we are interested in things such as intercepts with axis, intercepts with axis, turning points, etc. So that's the basic difference between the two, sketching and drawing. I think we had exhausted all that we needed on functions and transformation. Let's meet again in the next discussion. And like I said earlier, I'm pleading with you guys, let's share and like the channel as well as subscribing so that we can always receive notifications should latest posts be released. Bye for now.